Hello students, this is the third lecture on multivariable calculus. So in the first two lectures that were done in college, we have discussed the concept of limits of functions of two variables, and we have done several problems. So in today's lecture we will be discussing about the algebra of limits, and see how we can apply the algebra of limits in solving problems related to limits. So usually it's difficult to solve or evaluate a limit using the epsilon delta definition. So we need this algebra of limits or certain properties of limits with the help of which we can solve many of the problems. Okay. So the theorem, as you can see, is this: let f and g be two functions defined on some neighborhood of a point AB, such that this happens. Such that limit of xy tends to AB of f of xy, this is equal to, say, L. Okay, and limit xy tends to AB of g of xy, this is equal to M. Okay, then we have the following results: limit xy tends to AB of f of xy plus g of xy, this will be equal to L plus M. Okay. Similarly, limit xy tends to AB of f of xy plus minus g of xy this is equal to L minus M. Okay, and limit xy tends to AB, now we'll write about the product AB of f of xy multiplied with g of xy, this is equal to L multiplied with M. Okay, and the last one about the quotient, limit xy tends to AB of fxy by g of xy, this will be equal to L divided by M, but there are certain conditions, provided g is non-zero, g of xy M is not equal to 0, and provided g of xy is also not 0 in that particular domain. G of xy is non-zero, and in that neighborhood, in some neighborhood, okay, in some neighborhood, okay, in the domain, okay, in the domain, and M is also not equal to 0. Okay, so it's necessary that the function as well as the limit of that function g should be non-zero. Okay, only then we can talk about the quotient. Okay, so pardon me for the handwriting, it's difficult to, I'm not habituated to writing on electronic pad, so trying. So let us see or analyze the proof of this result. Okay, so for the first one, let's say let epsilon greater than 0 be given. Okay, be given. Okay, then since limit xy tends to AB of f of xy equal to L, so what we can write, and let us write it together, and limit xy tends to AB of g of xy is equal to M. Okay, so for this epsilon greater than 0, there exists a delta 1. So for the first function there will be one delta 1, and delta 2, they are greater than 0, delta 1 greater than 0 and delta 2 greater than 0, such that mod of f of xy minus L, this is less than epsilon, and whenever mod of x minus a less than delta 1, comma mod of y minus b is also less than delta 1, and what happens, mod of g of xy minus m, this is also less than epsilon, whenever mod of x minus a is less than delta 2, and comma y minus b is also less than delta 2. Mod of y minus b is less than delta 2. Okay, so now the same delta, a common delta, will work for both the cases. Okay, what is that common delta? If you just analyze, whenever mod of x minus a is and mod of y minus b is less than delta 1, and the first one is true, and whenever they are less than delta 2, the second one is true. So if I select the minimum of delta 1 and delta 2, okay, then whenever this mod of x minus a and mod of y minus b will be less than delta, both these two conditions will be satisfied. Okay, so let delta equal to minimum of delta 1 and delta 2. Okay, so we can write that, let delta equal to minimum of delta 1 and delta 2. Okay, then what we can write, then we have, so let me write it in the next page. Then what we have, that mod of f of xy minus L is less than epsilon, and mod of g of xy minus m is also less than epsilon, whenever mod of x minus a is less than delta, mod of y minus b is less than delta. Okay, so we have this result. Now let us have an idea. The limit of fx plus gy, f of xy plus g of xy is L plus m. Okay, so we need to compare between these two, f of xy. So let us write now, f of xy plus g of xy minus L plus m. Okay, let us compare this or find the value of this. So this can be written as f of xy minus L plus g of xy minus m. Okay, I can write it this way, and then I can use the triangle inequality. This is less than or equal to f of xy minus L plus mod of g of xy minus m. Okay, this way you can write, and then this can be written as less than epsilon plus epsilon. Okay, but I need this to be less than epsilon, the sum to be less than epsilon. Okay, so we can write epsilon by 2, because by the definition of limit, these for any given epsilon we can find a delta. So in particular for epsilon by 2 also we can find the delta. Okay, so in our earlier pages we just modify it according to our requirement. Okay, so I never write it directly as epsilon by 2, because we don't need to by heart these things. Okay, so I have told you several times, you start with this less than epsilon. Okay, so the limit concept says that, so that there is always a question why we should take epsilon by 2. We can take epsilon by 2 because the limit concept says that given any epsilon we can find some delta. So given epsilon by 2 also we can find some delta. Given epsilon by 3, epsilon by 100 or twice epsilon, given any positive quantity, we are able to find out some delta. Okay, so this comes from the fact that limit f of xy tends to ab, fxy is L. Okay, it comes from this fact. Okay, we are free to choose our this upper limit, the epsilon by 2 or twice epsilon, 3 epsilon. We can make it less than whatever we want. Okay, so that is what. So ultimately we can write it, this is less than epsilon by 2 plus epsilon by 2 under what condition? Whenever this is less than this, whenever mod of x minus a is less than delta and mod of y minus b is less than delta. Okay, so this is nothing but epsilon. So that means from here I can write, since epsilon is arbitrary, so we can write, so this implies that limit xy tends to ab of f of xy plus g of xy, this is actually equal to L plus m. Okay, so for the second one, so this is the proof. For the second one, I leave it to you as an exercise. You try to prove the second one. Okay. So let us go for the third one. So in third one, what I need to prove? I need to prove that limit xy tends to ab of f of xy multiplied with g of xy, this will be equal to L multiplied with m. Okay, I need to show this. Okay, so just let us try to analyze. We have our initially, let us take one epsilon greater than 0. Let epsilon greater than 0 be given. Okay, so let us find out this difference, f of xy into g of xy minus L into m. Okay, and let us try to bring in this triangle inequality. Okay, f of xy, g of xy minus let's say L into g of xy plus L into g of xy into minus Lm. Okay, you can write it this way. This is actually equal to, if I take fxy, g of xy common here, fxy minus L multiplied with g of xy plus, here I can take L common, and then this is g of xy minus m. Okay, and this can be written as less than or equal to mod of f of xy minus L multiplied with g of xy plus mod of L multiplied with g of xy minus m. Okay, so we can write it this way. Now our task is to make this particular quantity less than epsilon. Okay, so let us check which quantities we can make it less than epsilon easily. Okay, so this is mod of fxy minus L. This can be made less than any given epsilon, epsilon by 2, epsilon by 3, anything, whatever we like, because limit of f of xy is equal to L. This is already given to us, so we don't have to worry about this. We have to worry about this one. Okay, we have to worry about this g of xy term. We don't have to worry about model, so this is just independent of x and y now, and we don't have to worry about this term also, because limit of g of xy is already given to be m. So this particular quantity can be made as small as possible. Okay, so let us designate this inequality by the number 1. Okay, so we need to think about this particular g of xy. Can we make it less than what is our intention? Intention is to make this particular quantity less than some number. Okay, some fixed number which is independent of x and y. Okay, so let us see, can we do that, right? Okay, so we have limit xy tends to ab of g of xy. This is already given to be equal to m. Okay, so let us try to find out this an upper bound for this g of xy inside some neighborhood of ab. Okay, so for epsilon equal to 1, okay, there exists a delta, say delta 1. Okay, let us write this one as delta 1 greater than 0, such that mod of g of xy minus m, this is less than 1. Okay, so we are taking epsilon as 1 because this limit is m. We can make this quantity mod of g of xy minus m less than any positive number. Okay, so in particular we can make this quantity less than 1 whenever mod of x minus a is less than delta 1, mod of y minus b is also less than delta 1. Okay, under this condition we can make it less. So from here, can I write it this way? Minus 1 less than g of xy minus m less than 1 whenever this is already there, mod of x minus a is less than delta 1, mod of y minus b is less than delta 1. Okay, this is already there, no problem. So from here we can get an idea. M minus 1 is less than g of xy minus m plus 1. Okay, whenever this happens. Okay, so g of xy lies between m minus 1 and m plus 1 whenever mod of x minus a is less than delta 1, mod of y minus b is less than delta 1. Okay, can we make it simpler? We can also make it this way. Say mod of, I want a limit for mod of g of xy, so this can be written as mod of g of xy minus m plus m. Okay, I can write it this way. This is less than or equal to mod of g of xy minus m plus mod of m. Okay, we can write it this way. So yeah, so most probably I won't require these two lines. So this is less than or equal to mod of g of xy minus m plus mod of m. This is by triangle inequality, and this can be made less than 1 plus mod of m. Okay, 1 plus mod of m whenever mod of x minus a is less than delta 1, mod of y minus b is less than delta 1. Yeah, so I have got a approximate upper bound for this mod of g of xy in some neighborhood of ab. Okay, so that means now I am able to control the mod of g of xy. Okay, so I won't need these two lines. Okay, these two lines are not required here, so we can just avoid these two lines. Okay, so we have for epsilon equal to 1 there exists a delta 1 which satisfies this, and whenever and hence we can write hence mod of g of xy, which is equal to mod of g of xy minus m plus m. So this is less than or equal to this, and this is less than 1 plus mod m whenever this happens. Okay, so ultimately from 1 what we see, okay, so from 1, and so 1 gives mod of f of xy into g of xy minus lm. This is strictly less than mod of f of xy minus l into mod of into 1 plus mod m, okay, plus mod of l divided by mod of g of xy minus m. Okay, so we have been able to, so this happens whenever mod of x minus a is less than delta 1 and mod of y minus b is less than delta 1. Whenever sorry, this is also delta 1, mod of y minus b is also less than delta 1. Okay, whenever this happens. Now we have got an idea. we can make mod of f of xy minus L less than epsilon by 1 plus mod m. Okay, in that case, this particular quantity, the first term will be less than epsilon by, yeah, we can make it less than epsilon by twice 1 plus mod m. So this particular first term will be less than epsilon by 2, and the second term we can make it less than mod of g of xy minus m, we can make it less than epsilon by twice mod L. Okay, but there is a problem. If I write it as epsilon by twice mod L, it may happen that L is 0. Okay, so no, that's not a problem. We can always make it less than any other epsilon. So epsilon by twice mod L plus 1. Okay, so we need something which is less than 1. Okay, so that ultimately I can write it as ultimately this thing will be less than some particular value. Okay, so that's what. So now we can apply now since limit xy tends to ab of f of xy, this is equal to L. So so for above epsilon, okay, for the same epsilon, okay, the epsilon that we started with, epsilon greater than 0, there existed delta 2 greater than 0, such that mod of f of xy minus L, this can be made less than epsilon by twice 1 plus mod m. Okay, so we don't have to worry whether this is 0 or not, the denominator, because mod m is a non-negative quantity. With that I am adding 1, so this is always non-zero. Okay, so this happens whenever mod of x minus a is less than delta 2, mod of y minus b is also less than delta 2. Okay, this happens also since limit xy tends to ab of g of xy, this is equal to m. So for the same epsilon greater than 0, there existed delta 3 greater than 0, such that mod of g of xy minus m, this is strictly less than epsilon divided by 2 into say 1 plus mod L. Okay, this we can write. So we've added 1 plus here, so that the denominator is non-zero. Okay, so this happens whenever mod of x minus a is less than delta 3 and mod of y minus b is less than delta 3. Okay, so now what should be our next step? This let us name this as 2. Okay, so the next step will be, we will take, so the second inequation, it is true in the neighborhood of radius delta 1. The third one here is true in the neighborhood of AB of radius delta 2, and the fourth one is true in the neighborhood of AB having radius delta 3. So if we take the minimum of delta 1, delta 2, delta 3, all these three will be satisfied. Okay, so that is what we are going to do. So let us take delta equal to minimum of delta 1, delta 2 and delta 3. Okay, so what will happen? So and let us name these things. This one let us name it as 3, this one let us name it as 4. So 2, 3 and 4 imply, sorry, yeah, this one, what is that? Okay. So after this, yeah, we come to this. So 2, 3 and 4 imply that mod of f of xy into g of xy minus lm will be strictly less than epsilon by twice 1 plus mod m. Okay, this is already there, multiplied with 1 plus mod of m plus this will be epsilon by twice 1 plus mod l multiplied with mod of l. Okay, so this happens whenever mod of x minus a is less than delta and mod of y minus b is less than delta. So this is again strictly less than, so this first term is actually equal to epsilon by 2, but the second term is strictly less than epsilon by 2. Okay, so that is why we have written strictly less than epsilon by 2 plus epsilon by 2, that is epsilon. Okay, so that means given any epsilon, we have ultimately found out a delta which satisfies that mod of f of xy g of xy minus lm is strictly less than epsilon. Okay, so hence we can conclude that limit xy tends to ab of f of xy multiplied with g of xy, this is exactly equal to l into m. Okay, so this was the proof for the third one. Okay, and for the fourth one also we have a similar proof. Okay, so number 4 is we need to find out fx by gx. Okay, so here let us deal with a simpler case. Okay, we show that limit xy tends to ab of 1 by g of xy. Okay, 1 by g of xy, this is actually equal to 1 by m. Okay, and then we can use the third result. Okay, we can also do it independently, that's not a problem. Okay, so we show that this is actually equal to 1 divided by m. So since gx is greater than 0, g of xy, this is actually greater than 0, right, for all xy. So and m is also greater than 0. Okay, so we can use something here. So we have to use these properties. Okay, so let us try to find out what happens, try to analyze. Okay, so I want to show that this limit is actually equal to this. So let us observe what is this 1 by g of xy minus 1 by m. Okay, what is this? So this can be written as mod of if I take the LCM here, m into g of xy, and this will be just m minus g of xy. Okay, so this is nothing but 1 divided by mod m multiplied with mod of g of xy minus m divided by mod of g of xy. Okay, so I actually need so this is a constant term here. Okay, it is not dependent on x and y. This term g of xy minus m modulus, this can be controlled. Why it can be controlled? Because it is already given that limit g of xy is equal to m. Okay, so we can make it smaller than any arbitrary quantity. Okay, the only thing that we need to worry about is this. Okay, mod of g of xy. Okay, I want to or I will have to show that 1 divided by mod of g of xy is less than some quantity. Okay, 1 divided by mod of g of xy is less than some quantity. Okay, so what we can do here? Okay, so we are already given that m is not equal to 0, given that m is non-zero. Okay, so if we just take, given m is non-zero and limit xy tends to ab is equal to of g of xy, this is equal to m. Okay, so for say epsilon equal to m by 2. Okay, for epsilon equal to m by 2, there exists a delta 1 greater than 0 such that mod of g of xy minus m, this is less than m by 2. Whenever mod of x minus a is less than delta 1 and mod of y minus b is less than delta 1. Okay, whenever this happens, right? So now we can just simplify this. So this will be minus m by 2 is strictly less than g of xy minus m. This is strictly less than m by 2. Okay, so whenever this particular thing happens, so this will imply that m by 2 is strictly less than g of xy, and this is less than 3m by 2 whenever mod of x minus a is less than delta 1, mod of y minus b is strictly less than delta 1. Okay, so but m by 2 is a is a positive quantity because m is positive, right? Oh sorry, m need not be positive. Let us write it as m mod m by 2. Okay, mod m by 2 is positive, right? So this can be written as mod m by 2. So mod of g of xy minus m, this is strictly less than mod m by 2, and then we can simplify it, right? Mod of m by 2. Okay, so let us go to this next page. Mod of m by 2, this can be written as mod of m. I need something like g of xy is strictly greater than something. Okay, so for that what do I have? Mod of m, this is equal to mod of m minus g of xy plus g of xy, and this is less than or equal to mod of g of xy minus m plus mod of g of xy. So from here itself we can have something, right? This is strictly less than m by 2, mod m by 2, right? Mod m by 2 plus mod of g of xy. Okay, whenever mod of x minus a is less than delta 1, mod of y minus b is less than delta 1. Okay, so here we have got it now. So just let me remove this. So we have mod of m can be written as this. So just let me edit the last page. So given m is not non-zero and limit xy tends to ab of g of xy is m. So for epsilon equal to mod m by 2, okay, there exists because m may be negative. Okay, so earlier I made a mistake there. So m may be negative. So let us take epsilon equal to mod m by 2. So then there exists a delta 1 greater than 0 such that this happens. Mod of x g of xy minus m is strictly less than mod m by 2. Okay, so this part is not required here. Okay, please edit this part. Okay, so after this step we just come to the next step. So mod of m can be written as mod of m minus g of xy plus g of xy, and this is less than or equal to mod of g of xy minus m plus mod of g of xy. So ultimately this is strictly less than mod m by 2, and plus g of xy. So ultimately we have got mod of g of xy. This is actually greater than mod m. So mod m by 2 goes that side, so mod m divided by 2. Okay, so from here what I've got, so this is true whenever mod of x minus a is less than delta 1 and mod of y minus b is less than delta 1. So from here I have got 1 divided by mod of g of xy. This is strictly less than 2 divided by mod m whenever mod of x minus a is less than delta 1 and mod of y minus b is less than delta 1. Okay, so we have got this now, right? So we can substitute in this particular thing. Yeah, so here we can make some substitution. So we have got 1 divided by mod of g of xy is less than 2 divided by mod m. Okay, 2 divided by mod m. So let us name this as 1. Okay, so we have hence, yeah, so 1 implies 1 and 2 imply, so let us name this particular thing as 2. This one, let us name this one as 2. So from 1 and 2 imply that what is happening, mod of 1 divided by g of xy minus 1 by m, this quantity is strictly less than 1 divided by mod m multiplied with mod of g of xy minus m divided by 2 mod of m. Also, sorry, 2 divided by mod of m. Okay, so this 2 is not here, it's in the numerator. Okay, right? So 2 divided by, so that is actually 2 by mod m square multiplied with g of xy minus m. Okay, now it's very simple. We can this control this quantity. So this particular thing is true whenever mod of x minus a is less than delta 1 and mod of y minus b is also less than delta 1. Okay, now for above epsilon, or for given epsilon greater than 0, there exists a delta 2 greater than 0, such that what happens, mod of g of xy minus m, this can be made smaller than epsilon by 2 into mod m square. Okay, this is what I need. I can make this quantity strictly less than this epsilon by 2 mod m square. Okay, so if I do that, this whenever mod of x minus a is less than delta 2 and mod of y minus b is less than delta 2. Okay, so let delta equal to minimum of delta 1 and delta 2. Okay, in that case we can substitute, and in the next page we will get, hence mod of 1 divided by g of xy minus 1 by m, this is strictly less than what was that, 2 by mod m square into epsilon by 2 into mod m square. Okay, right? So this is actually so whenever mod of x minus a is less than delta and mod of y minus b is less than delta, so this is actually less than epsilon. So therefore what I have proved that limit xy tends to ab of g of xy is, 1 divided by g of xy, this is equal to 1 divided by m. Okay, then we can apply the third one. Applying the third result, what we have, limit of xy tends to ab of f of xy by g of xy. Okay, this can be written as what, this can be written as limit xy tends to AB of f of xy multiplied with limit xy tends to AB of 1 by g of xy. Okay, and then this can be written as L divided by m. Okay, but we need to be careful whenever we are splitting the limits in this form or in the addition form. We have to make sure that both the splitted limits exist. Okay, otherwise the splitting doesn't make sense. So here I am splitting limit xy tends to AB f of xy. This should exist finitely as a limit. Okay, only then I can split. This also should exist finitely as a limit. Only then I can split. Okay. So this was about the theorem. So we will do more in the next class.